Hello everyone. Let's begin with something simple. Imagine your classroom. Suppose the rule is the height of each student must be less than 160 centimeters, or the classroom can hold at most 60 chairs. Notice these are not equations. Nobody said height equals 160 or chairs equals 60. Instead, we have restrictions less than, greater than, less than or equal to, greater than or equal to. Equations describe perfect balance. Inequalities describe ranges of possibilities. That's why they're so useful in real life. Formally, to real numbers or to expressions related by the symbols less than, greater than, less than or equal to, or greater than or equal to form an inequality. Examples: 3 less than 5, written as 3 is less than 5, 7 greater than 5, written as 7 is greater than 5. Literal examples with variables: x is less than 5, y is greater than 2, x is greater than or equal to 3, y is less than or equal to 4. Sometimes we chain inequalities. For example, 3 less than x less than 5, meaning x is greater than 3 and less than 5. Another example, 2 less than y less than 4. These are called double inequalities. So equations tie down a single value, but inequalities describe a whole set of values. Now some standard algebraic forms. Linear inequalities in one variable: ax plus b less than 0, ax plus b greater than 0, ax plus b less than or equal to 0, ax plus b greater than or equal to 0. Linear inequalities in two variables: ax plus by less than c, ax plus by greater than c, ax plus by less than or equal to c, ax plus by greater than or equal to c. Nonlinear example: quadratic inequality: ax squared plus bx plus c less than or equal to 0, or ax squared plus bx plus c greater than 0. Here a is not equal to 0, and in the two-variable case b is not equal to 0. So inequalities can be linear or quadratic, strict or slack, but they always impose boundaries. Two categories: strict and slack. Strict inequalities use less than or greater than. Example: ax plus b less than 0 or ax plus by greater than c. These exclude the boundary point. Slack inequalities use less than or equal to or greater than or equal to. Example: ax plus b greater than or equal to 0 or ax plus by less than or equal to c. These include the boundary. On a number line, strict x less than 3 is shown with an open circle at 3, slack x less than or equal to 3 is shown with a filled circle at 3. Quick tip: always check if equality is included. Many exam mistakes happen here. Consider Ravi going to the market with 200 rupees. Each rice packet costs 30 rupees. If x is the number of packets, spending is 30 times x. He cannot exceed 200, so we write 30x less than 200. Divide both sides by 30, x less than 200 divided by 30, which simplifies to x less than 20 over 3. Now, by domain, if x is a natural number, valid solutions are 0, 1, 2, 3, 4, 5, 6. If x is a real number, the solution is all x less than 6.6 recurring. So the same inequality can yield different solution sets depending on the domain, naturals, integers, or reals. Now to two variables. Reshma has 120 rupees. A register costs 40, a pen costs 20. If x is registers and y is pens, then condition is 40x plus 20y less than or equal to 120. The equality 40x plus 20y equal to 120 is the straight line boundary. The inequality means all points on or below this line are valid. So inequalities in two variables do not give single values, they describe shaded regions or half planes in the coordinate plane. Now a worked example. Solve 5x minus 3 less than 3x plus 1. Step 1. Subtract 3x from both sides. That gives 5x minus 3x less than 3x plus 1 minus 3x. Simplify 2x minus 3 less than 1. Step 2. Add 3 to both sides. That gives 2x less than 4. Step 3. Divide both sides by 2. That gives x less than 2. So the solution is all real x less than 2. Interval notation, open interval from negative infinity to 2. Graphically, open circle at 2, shading all values to the left. Important reminder, if you multiply or divide by a negative number, flip the inequality sign. For instance, 3 greater than 2 becomes negative 3 less than negative 2 after multiplying by minus 1. Let's recap. Inequalities extend equations using less than, greater than, less than or equal to, greater than or equal to. They are classified as strict or slack. They can be linear in one variable or two variables. Real-life examples, budgets, capacities, exam cutoffs. Graphical representation, shaded intervals on number lines or shaded half planes in two variables. Solution sets depend on whether we are working in naturals, integers, or reals. And that's the essence of inequalities, a powerful way to describe ranges instead of single values. In our next session, we'll explore systematic techniques for solving and graphing them.